I think if I can contribute to this paradigm shift, that will be kind of like my life, well, professional life goal, because I think it's almost an ethical imperative in a way, which is I mentioned that we're going to spend more than a decade in a sick state. Is suffering at the individual level, at the family level. And on average, every single one of us is going to have to go through that. It's just the journey of life. But does it actually have to be that way? And how much can we actually ameliorate that?
Imagine a future where the last decade of life isn't marked by decline, but by vitality, where the measure of our progress isn't how long we live, but how well. Dr. Diogo Barardo stands at the frontier of this possibility, using biological age clocks, multi-omics, and rigorous data to shift the conversation from treating disease to targeting aging itself. His journey from physics to longevity science is more than a career arc. It's a call to rethink what's possible when science stops accepting decline as inevitable. In this conversation, you'll discover how data ethics and vision can converge to compress the sick years, expand our health span, and redefine the arc of human life. And you'll hear why this shift is not just desirable, it's necessary for the future we all share. Dr. Diogo Barardo is a scientist at the bleeding edge of aging research, both in academia and the consumer health space. From building the world's most comprehensive databases on longevity, drugs, and compounds to pioneering aging clocks that measure biological age with unprecedented accuracy, he has dedicated his career to decoding aging's hidden logic. And now at NOVOS Labs, he's translating these breakthroughs into accessible evidence-backed interventions for the public. Dr. Barardo's work challenges the simplistic anti-aging promises and replaces them with hard-won, nuanced, and actionable knowledge. His journey, just perfectly reflects what we do here at the DNA of things, and bridging rigorous science, personal responsibility, and the possibility of reshaping our biology and our destiny. So not with magic bullets, but with well-informed ethical choices and how we live and age. And so without further ado, Dr. Diogo Barardo, welcome to the DNA of Things. It's so great to have you.
Thank you so much, Jeremy. I'm excited about our conversation.
Yeah, it's been a long time coming. I know we initially chatted. It feels like probably only like months ago, but it feels like years. I've been really itching to have this conversation. We have, I would say, similar past insofar as like the academia experience and then bridging into the entrepreneurial space. So, but before we kind of dive into what you're doing now, something that really stuck with me from our last conversation was this notion of like negative synergy on complexing even things as simple as supplements. So I do want to dive into like what you're doing now insofar as age clocks, but I want to make sure we spend a little bit of time on that aspect of things, because I think a lot of people are out there doing these N of one self-experimentation initiatives and not realizing they might be doing more harm than good. But anyway, before we jump into all that, maybe if you could share, how you got to where you are. Tell me a little bit about the man behind the mission.
Sure, with pleasure. So I think, since I remember, I always wanted to be a scientist. I just didn't know in what. So I was very good in school, across all the academic fields, but I didn't have a passion. Like, I didn't know exactly what I wanted to do. So I just went for physics, because that is like what smart people should do, is physics kind of thing. So kind of pushed to it. But then I actually saw a TED talk from this doctor called Aubrey de Grey that was basically teaching that aging is a problem, is actually a health problem, and we can do something about it. And when I watched the TED talk, I was like, okay, let me actually, search this, really see if this guy is just full of these big claims and there is no substance. And it turns out that that's when I discovered about the zero science hypothesis, which, maybe to just communicate to your listeners, basically, is the idea that since aging is a primary risk factor for most of the chronic diseases, most of the mortality risk is due to chronological age. Then, if it would be possible to target aging itself, then as a consequence, you basically get decreased risk of all these different types of mortality and decreased incidence of all these type of chronic diseases. So I thought, okay, so targeting aging sounds like a very good idea, but is it actually targetable? Can you actually do anything about it? And in '93, there was this canonical paper, which I found on the internet by myself, which basically was from this researcher, which now is one of the giants in longevity research, called Cynthia Kenyon. And she basically showed that in these model organisms, these microscopic worms, if you just manipulate one gene out of the 20,000 that these organisms have, you could actually double lifespan. And that was just the start. And this was reproduced with different genes, different organisms, all the way to mice. So at that point, I kind of like my passion found me in a way. So I immediately switched fields to biology midway through the course, and just decided to become a longevity scientist. So from then on, I did my master's, my PhD, and my postdoctoral degree in aging itself, targeting aging itself. So no neurodegenerative disease, no, anything associated with aging per se, but the aging process itself. And it has been my passion. And yeah, that's like a very short summary.
Wow. So I want to dive into like what that one gene was, and obviously the paradigm of age itself as the root cause, or chronological age itself as a root cause. But I did ask that question about the negative synergy, and maybe those things are somehow related, right? Because I think oftentimes folks are pursuing nutritional interventions to get some kind of short-term performance outcome, but with the long-term in mind. So maybe we can connect those two things, because I know you built this really cool database with like the drug age database, for example. So maybe we dive into that and then jump over into this root cause analysis and looking specifically at chronological age. Does that sound good?
Yeah, sounds perfect.
Yeah.
So
Okay.
so during my master's, I had several projects in my master's thesis. I actually get 4 papers, which is kind of like a record. And one of them was using machine learning to predicting new compounds that might extend lifespan, for example. But I think the one that actually brought me most attention was that I did drug age. So drug age is a public database. You can just Google it, drug age, and it's going to be the top hit on Google. It's freely available, and it's basically a database that all the scientists use to check if a compound, so this could be a pharmaceutical compound like a drug, it can also be a natural compound, from green tea, let's say, has ever been shown to extend lifespan in a model organism. So the idea here is that we cannot test things in humans, even if it's something healthy, because obviously you need to wait decades to kind of have a readout on the experiment. So we use model organisms as proxies. And this database tracks every single thing that was ever shown to extend lifespan. And so I did that because I was actually compiling it myself for my personal use. And one day my supervisor, I was doing an Excel spreadsheet in the office. My supervisor kind of caught me. And then he's like, we should turn this into a community tool. And that's the history behind it. So then I guess now it kind of like is a good segue for the combinatorial approach, which is this I did in my master's. And then on my PhD, I actually had a lot of freedom. I was very blessed in that. And my idea was, okay, now I compiled, everything that has ever shown to extend lifespan in a model organism. What if I pick, a few of those things, let's say a dozen, I combine them in pairs, and hopefully I would have an intervention that actually has a larger effect size, so it has more effect. So the idea would be, if there is a molecule that extends lifespan, and there is another molecule that also extends lifespan, we kind of know a little bit about the way, or at least we have suspects of the way they are extending lifespan. So if they are targeting different things, I put them together. Hopefully, I would have an effect that is larger than A and B. This additive or synergistic effect. So this is, of course, very relevant for, these N equals 1 experiments that you're talking about, people that create their own, supplement stocks and so on. especially for longevity. And to my surprise, my hypothesis is that I'm going to be successful in this. To my surprise, I basically refuted my own hypothesis. So it turns out that synergies are quite hard to get, even if you combine interventions that individually they have a beneficial effect. The majority of things is going to be equal or worse than the best of the single interventions. So maybe a way to kind of unpack that is that if something extends lifespan in this model needs by 5% and the other thing by 10, if I combine them, the great majority of pairs is going to be 10 or less. So about a third, about 20% is additive. So I actually get, in this case, I would get like 15%. About 10% is synergistic. So I get more than the sum. But there is a lot of things, and surprisingly, there are toxic things, which was the thing that you were alluded to, that when you pair two things that are beneficial to you, you actually have a negative, a dyssynergy, a negative interaction. And they actually make these model organisms live shorter than the control group. It's about 10% of the cases, which is about the same as the synergies. So you can see that like the scale is slightly tipped negatively, which of course, I think it has a lot of relevance for these longevity stacks. And I'm guilty of that too, obviously, because I tried a lot of things on myself. But yeah, there is this human tendency to just pile things up and expecting additional benefit. And the data doesn't support that.
Yeah. Well, and the interesting thing too is the synergy observed, positive or negative, in one person may not be true for another. Right. So I don't think it'd be necessarily, we tend to do that, right? We're looking for the roll up silver bullet. And I think what we're finding more and more is like, well, the way to treat everybody the same is to treat them differently. Right. But, I had this conversation with Nick Price over at the Buck Institute and also at Thorne. And, a couple of things, on the topic of synergy, particularly in nutraceuticals, we touched a little bit on that, is like finding your own, precision blend based on you, based on your DNA, based on your history, based on your bloods, based on things that we can measure. But then also in terms of maximizing health span, which I think might be important to discern the difference between those two with respect to longevity, like longevity versus health span, whereas longevity is how long can you live, and health span is how much of that life can be, of the highest quality, choosing a particular range as high quality, maybe not quite peak performance, but, certainly, maybe peak cognition and, minimal pain. We can define all that. But the point is you do want that window. And one of the things that, he helped me with was when I look at like an athlete, I gave him the decathlon mental model where it's like, hey, if you're a decathlon, you compete at the Olympics, a good strategy is to be world-class in 2 to 3 events and just kind of average in the others. And so to be world-class in 2 or 3, you kind of look at your innate talents and you really ratchet those up. And, that's a good strategy for winning gold. It would be hard to win everything and to, bet your averages so completely on kind of an even distribution. I don't think pays dividends. Now, what Nathan said was, he's like, well, actually, in Healthspan, it's the opposite. So you actually want to know what your weakest link is and focus on that. So if I take like the top 10 diseases that are, we have some kind of measurable risk against that, the folks, all of us are working on, and I take like my top 10, measurable chronic diseases, like say cardiometabolic health or autoimmunity and different cancers, et cetera. I can rank those in terms of priority based on my genetic predisposition and my health history, et cetera. And then it's like, I focus on that one thing until it's not a thing, and I build the habits and I de-risk it. And then I keep going, to continue de-risking everything. But coming to your approach, your paradigm is like, well, underlying all of that, there's this deeper root cause, which all of these things are on top of. And so, and you said that was maybe it was wrong in saying chronological age, because you can't fight that, but biological age. And I think there's this idea that you want to get your biological age optimal. And that's probably also going to address the health span issue, because, health span probably tends to be within a particular range. So how do you, so picking up on kind of that mystery gene. So what was the gene that doubled our possibility for that? And how do we activate it? And sorry, I guess what was that gene? Is it linked to this biological age? And then if so, how are we activating it in its various forms? Because we're each potentially going to have a different form.
Yeah, sure. So I think so. The gene itself, it was actually is known because the effect size was so large. Double lifespan makes headlines, and indeed it made. There is a lot more genes. This is still one of the main ones that we study in aging. There is literally hundreds now, at least in model organisms. And this specific one is related with the insulin pathway. So you can think about it as like the growth pathway for the human body. In this case, the what they did to the gene is they kind of removed it, scientifically speaking.
And sorry, what was the name? What was the name of the gene?
So in worms, it's called DAF2, DAF2. So
in worms, you mean like nematodes?
Exactly.
Gotcha.
But it has an analog in. It's basically a very well conserved pathway. So this would be like the insulin pathway in humans. So basically, this would be the opposite of what the intervention was. You can think about it as being like in really high dosage of like steroids and a lot of these muscle building drugs. That will be kind of like activating that pathway. And what we did was we kind of you kind of remove that pathway from the animal. We not totally remove, but basically, practically speaking, reduced by like 90% or something. I was actually going to tell you that other thing about Healthspan, because I just happened to reread that paper just now, today, because I was curious about the US example, and I actually checked the Healthspan metrics. So we have this thing that we track across all nations, basically, which is called the Healthspan lifespan gap. So at the population level, what is the amount of years that people live? And of those years, how many, in medical terms, they define as chronic disease-free or disability-free? And I think one thing that I think no one appreciates, and even myself, I sometimes forget, is that we basically have, on average, at the population level at least, so if not us, because we're trying to do something about it at the personal level, at least some of our family members, on average, we have about slightly over a decade of life that is not our last decade, slightly over it, is not spent in good health. So, for example, I can give you the numbers that I just checked for the US, which is for your female listeners, for example. On average, you're going to outlive your husband by almost 5 years, it's 4.5. But of those are actually spent in bad health, and you spend almost 14 years on average with compromised health. And for males, although we live shorter in the US, is 76 is expected, is average life expectancy. 11 years are spent in compromised health. So the idea is that by targeting longevity itself, we can kind of just compress this year spent in bad health and maybe actually add a few on top of it. That's kind of the idea.
Just jumping back to like the insulin pathway as, kind of the central, let's say, target. Now looking at your drug aid database, it's like, looks like the second most researched drug is metformin. Right. So, and I think that's now being, prescribed, specifically with individuals with like a higher type 2 diabetes risk, or at least that was a discussion that I had with a clinician recently. I don't know that that's widely prescribed, but yeah, just in terms of like, sorry, go ahead.
No, it's the first line of treatment for type 2 diabetes in general.
Yeah. But even like, is it now a preventative? So I guess that's my next point is okay. So we've got this insulin pathway as maybe a master pathway, but we've got hundreds of other genes, and I think really what we're saying is we have a way to measure your predisposed biological age and the biological age that you're manifesting, and then some kind of intervention. Is that kind of well, how about I ask a more direct question, like for example, you are now on the other side of your PhD, and I mean maybe let's do that. Let's share a little bit about what you're doing today, specifically, and your role in industry.
Sure. So I'm director of R&D at NOVOS Labs right now. So I left academia. I'm still collaborating in a lot of academia manuscripts, so I haven't really left at all. But yeah, just more
Mm,
hours, I guess. So I have like, I would say there are two things that I'm interested on. One is that it kind of bothered me a lot that a lot of the supplements out there have very little evidence. And we're not even talking about the complexities of combining things together, but a lot of them. It's just a lot of hype. I would say the great majority. So my idea was, can I, I know the pathways. Can I actually design things that are superior? So that's what I've been doing at Novos. Design a product line that should be helpful for the majority of people in terms of targeting the aging process itself. How much is moving the needle? We don't actually know. We have a few readouts that I can talk more about later, but it should be those things of like no harm and potentially beneficial. Since
mhm,
you're going to, so the idea for the consumer would be, if you're going to take supplements, instead of going with the latest trend or whatever people are pitching, these next 3 months, you kind of let someone, scientists that understand aging, because we have quite a broad scientific advisory board, create a stack for you that actually is evidence-based. So this is the idea. On the other side, the thing that interests me a lot is how to track aging. So obviously, if I want to improve something, I want to have some kind of readout that I'm improving. I cannot wait myself to get a disease or you know anything worse happen to then see, oh, I was actually on the wrong path. I should have stopped taking this. So I want something that is able to track at the individual level, and this is a huge barrier, technically speaking, that just very recently we were able to surpass because a lot of the tools we use in studies is like as long as it's good enough to track population differences, it's good enough for us because you can do papers, you compare control group, experimental group, and that's fine. But at the individual level, it requires completely different degree of accuracy. In this case, reliability is a technical word. So that's what lately I've been working on a lot too, is kind of come up with new ways to track aging or improved ways. So we have this thing called biological aging clocks, which is just a very long word to say the age that, instead of the passport age, is the age that your biology more resembles. So if it resembles an age of some cohort that is older than you, it's probably a bad sign because it puts you in increased risk of different mortalities and diseases. And if it resembles biology of a cohort that is younger, you're probably slightly protected against all this.
got
Sorry.
it. Yeah, take your time. I'm just you know revisiting the site since we last chatted, and I forgot how blown away I was because you guys are like you're putting together these blends, um, cognizant of positive and negative synergies, but you also do like the omics tracking as well. Like so is the idea here like, okay, take this supplement and we can track your biological age and we can track your improvements. We can actually show that it's working. Is that accurate?
Yeah, exactly. So basically, it empowers the customer to, they can scrutinize if it's working for them at the individual level or not, the intervention. And if it's
Hmm.
not, they can just stop taking it. And maybe they try something else, even from other company. The idea is that we are completely transparent. So all the results that we provide from people have to do this fingerprint test, they send to the lab. We don't touch anything. Like it's all third parties. So, we completely independent. And I think we like this approach that the consumer can see for himself if it works or not.
Hmm. So you guys are just kind of the wrapper pulling all these things together, putting it together in like a transparent way. So, okay, so that would mean, but so in terms of the age test, because you worked on and developed a lot of these age clocks, are they using like the science you developed, or are they leveraging like free open source models? Like how does that work?
So this test right now, it actually was commercialized even before I joined Novos. So this is the most famous and also the most reliable. So it's actually the only one that probably, arguably there are two, but I would say is the best of those two anyways, that is the most reliable. So it allows you to track at the individual level. So the idea here is that, imagine if you have a scale in your bathroom, if every time you step on it every day, you have your real weight plus or minus 10 kilos. It's probably not very helpful as a scale. So we had that issue because we didn't really care, because if you have these big errors at the population level, they average out. So you're still good. But for individual level, it's crucial to have this very granular reliability. So this aging test is based on epigenetics. So you have your DNA, and then you have the epigenetics is basically your DNA is very long in the cell, like really, really long. So it cannot be stretched out to be readable at any time. So it's basically all folded. And the parts that are very, very folded, they cannot actually be read. So the epigenetics controls which part are read or not. So that means that the actions of your genome, its potential, it's limited by the epigenetics. And what we scientists did with this is that they measure that across age, there is a signature at the epigenetic level that is really good at predicting chronological age, and then new generational clocks that predict mortality risk. And so we call that a biological aging clock. So if you are able to move this and make your epigenetic resemble someone that is younger, you actually should have a decreased risk of all-cause mortality and the incidence of several age-related diseases.
Right. Okay. Sorry, go ahead.
No. So that's the test in the kit. I developed tests that were basically on combining multiple omics, so not epigenetics, but there's also, I was part of a lipidomic clock, so in lipids. I developed a proteomics clock, so a clock using protein. So basically finding these signatures across different layers of biology.
Right.
And they're all
was
there. Yeah.
Right. Yeah, that was exactly my next question. So there's the epigenetic layers. That's what we're seeing at the level of, what genes you're expressing, transcription. But then you're looking at signatures like in the cells in terms of what proteins are showing up, and then, what the cells are made of in terms of their lipid structure. And then do you do the genomics as well, the DNA? Because I look at, I think I think genomics got a bit of a bad rap because they're like, oh, it's, there's how much can it really tell you? It's like, I think actually like a lot, like in terms of, root cause and how to prioritize. And I think we're only getting better at understanding how you might kind of make some critical adjustments in the rudder early in your life. Of course, like these, like the epigenetic clocks and the proteomics, it's like those are the things that, you can action and change and measure quickly. So I'm always fascinated at folks who are like harmonizing all the way up. And it sounds like that's probably, if you're not doing it now, that might be a path that you're on.
So genomics is interesting. It was also the first omics, basically. That's the first thing that we cracked with the genome level. So there are a few things that is important to take into consideration, which is, I also did my genomics, by the way, in a sequencing company. We don't do genomics at NOVOS. So I can tell I was also excited about it, but it's kind of in a different way. So genomics is more, do you have one of those key player genes that actually are, can really make a difference in your health? We're talking about ApoE for Alzheimer's, we talk about BRCA for breast cancer, so on. If you're kind of free of those, it's not trivial to kind of understand, just based on genomics, what's going to be your outcome in life. So it's kind of like, if you don't have any giant limiting factor, then it's kind of, it's a very gray area, genomics, the polygenic risk scores that we have. I personally did it, but on top of that, there are two other considerations. First of all, it's not modifiable, as in you can do something about it by changing your lifestyle, but you cannot really modify your genes, right? They are for life. While epigenetics, which is, for example, is that gene going to be read very easily or not, can make a difference. So you can track interventions using epigenetics as a readout. And the other thing is that genomics have individual data, which, as you know, there have been breaches basically across every single company that does genomics, there has been a data breach. While epigenetics, there is individual data, but it doesn't say anything about the individual. Like if you have some kind of mutation, we cannot see it. We can just see, is this chunk of the genome readable or not? So it's very different from the consumer point of view, for example, in terms of data protection. So, but I do think that I think it was like 2 days ago, or maybe yesterday, there's just 500,000 people were sequenced finally the genome in the UK Biobank. And that's going to have insights of all kinds that we cannot even, understand. So it's super exciting.
So you essentially at NOVOS right now are in charge of like directing the multi-omics platform and also the interventions that those would point to. Is that correct?
Right now, we are just single omics, which is epigenomics, epigenetics. We are very excited maybe about some other omics, like for example, proteomics, but right now we don't have any product line with it. So yeah, the idea is that can you track aging? We also have, for example, a free app that has a biological aging clock that is based on the questionnaire, which is scientifically validated. Obviously, there are limitations of being a questionnaire, but it's free, you know. And the idea is that we're trying to offer solutions and also ways to track if the solution is working or not at individual level to empower you. So, yeah.
Have you thought at all about microbiomics? You mentioned proteomics. You think about microbiomics?
So I had a little gap between my PhD and a postdoctoral degree because of COVID of about half a year. And I actually worked for a microbiome sequencing company in Singapore. And it was, first of all, it's super interesting, really, really interesting. Second of all, it's really, really noisy data. I tried to build a biological aging clock using that omics, and it was the only one that I was not satisfied with. I can give you an example. The error in the clock was about plus minus 8 years, which is way above what, will be viable. And so far, there have been a few other companies that published their clocks and some other scientists. And that trend seems to be it kind of seems to be like everyone is arriving to like these very large error clocks. And my idea is that it's just too personal and it fluctuates too much based on whatever you ate, at what time you ate. And so it's too responsive. So it's not so good as a tracker. Of course, there are exceptions. For example, I remember that there were people that they had a microbiome that they basically had one species that's literally one single bacterial species that was the majority of the microbiome, and they had a lot of issues, gut health issues. So the cause is very apparent when you see that, for example, if someone comes and 90% of the microbiome is the very same species, that's basically zero biological diversity on the microbiome. So it's quite interesting, I think, for health conditions, for general aging, especially if you are relatively healthy. It seems to be a biological layer that is very noisy.
Yeah. Well, I mean, I had direct experience with that in terms of research that I did as a postdoc, looking at how the infant gut in humans is colonized. And we just did a case study just to kind of, more for like a hypothesis outcome, right? It was like, let's observe it and let's see, right? In hindsight, obviously you can't really do it like a specific trend analysis with an N of one, but you can start to see, oh, well, when I switch from breast milk to formula, there is that perturbation. That makes sense. When I introduce antibiotics, that makes sense. When I introduce new foods, that makes sense. So I mean, it was interesting to see that. I think one of the other things that just kind of emerged as a hypothesis was, well, maybe there is a core microbiome that, if your gut gets decimated, you get like food poisoning, or you got to take antibiotics, it reflourishes with a consortium versus a single probiotic. So, should we be thinking about health interventions more as like a community of microbe solution versus, our top 10? Something I learned about actually just the other day, and this is actually from a future guest that I've got scheduled here. I just want to make sure I get it right. Yeah, Sean Gibbons, who's a gut microbiome guy. I think it was him that said, don't hold me to this, but I'm pretty sure it was him, on the notion of, like a healthy gut microbiome, like an aging microbiome, actually something that might be good for, youth or in your prime is actually not necessarily good for a well-balanced, well-aging, fine wine, let's say, human being, right? So you wouldn't want like to put the microbiome of a 30-year-old into the microbiome of a 70-year-old. You probably wouldn't want to do that anyway. But to me, it's an indication that it is really synergistic with all systems. But you did say something that made me pause, which is, oh, it's so responsive and it's so quick. So I've heard a lot of people that are offering these tests, they talk about the richness, the diversity that you already outlined. And then, yeah, is there something, clinically relevant to watch for? Obviously infant development is a very focused area. I've heard about the performance microbiome for athletes, but you said something that I didn't think about as a measure, which is the responsiveness of your microbiome. So, because you're right, to go and be like, oh, we're going to test you every month or every week. I know that's not enough. I've seen the data. Like, we did the correction analysis where, we do 3 or 4 points a day and then breaking that sample down. And so, there's variation even within the sample. So you have to correct for all that. Assuming you do, that is an interesting application, which is how responsive is your gut microbiome, right? So, okay, but then, so if you're going to say how responsive is it, it's like, well, then how responsive to what? So it might have to be a clinical application or, just a very controlled set of environmental circumstances. So, if you have to have, chemotherapy or cancer treatment, or, if, you're working on, I think any kind of health plan, it would be interesting to have a more deliberate tracking to see how the microbiome responds. And I don't know if it's a measure, but I would suspect that it is, if it's working synergistically with you, because like, oh, here's a new diet, here's a new stressor, and so just having that as a new metric might be interesting. But that's for somebody else to do the work to validate something like that.
Yeah, yeah.
Yeah.
So I think the microbiome is very interesting from a mechanistic point of view, which is that basically your body is made of just a bunch of molecules and you acquire them through diet. And every
Hmm.
single molecule that you acquire has to physically pass through the microbiome. So
Hmm.
there is literally nothing that you can put on your body that is not going to pass through the microbiome. And so
Hmm.
I think just from that, it has a huge implications for health in general. I can also tell you that just recently, I think like in the last week, there was a study that they transplanted microbiome from a young mouse to an old mouse, and
Hmm.
they actually it seems to delay aging basically. So all the
Hmm.
things that you can measure in mice, basically they got better, so they look younger. So
Hmm.
it's quite interesting. Now these are mice that are already adults; they are young but adult. If I recall correctly, I think what you're mentioning is this concept of antagonistic pleiotropy, which is basically that there are things in your development. So when you're growing up, from a baby to a kid to a teen to a full adult, that your organism is doing it. Like one of those, for example, is the DAF2 pathway that I told you about, the insulin pathway, the
Hmm.
mTOR pathway, the
Hmm.
growth pathway. That is
Hmm.
required for you to grow. Like you just literally are
Hmm.
acquiring more mass as an organism. But you don't keep acquiring mass indefinitely. There is a certain point that you reach your height, your body weight, and so on. And so there is an entire genetic program. We call it program. So there is an entire genetic signature that basically shifts when you reach adulthood. And this theory says that there are genes that they are essential for development. They actually have a negative influence on health once you are developed, eventually, with age. So I think this person was applying that concept to the microbiome, which is quite interesting. But I never heard it before. But yeah,
Hmm. Yeah. So I think you never heard it before because I think the idea just came because of this conversation, right? Like, so you get 50% credit in it if that's true. But that is an interesting point that you highlight there, and insofar as life cycle dependent transcription, right? So like we're looking at epigenetics as age clocks. Is that a service that exists as kind of like a general kind of health tracker as part of, like let's just say I wanted to give the best, most thorough dashboard available to the next generation, right? And not to be like the ultra molecular helicopter parent, just to basically say, well, here's the most objective measure that we have. Has anybody talked about having like a life cycle, specific? It wouldn't be an age clock. It would be like basically an epigenetic
yeah,
profile.
exactly. So that exists
Yeah.
for preterm babies, especially. There exists
Interesting.
maybe half a
Hmm.
dozen pediatric, let's call it pediatric aging clocks. So they,
Hmm.
they are useful in the sense that they track if the baby is catching up, basically. If there is some kind of delay
Interesting.
at the epigenetic
Okay.
level. They're quite they're
Mm-hmm.
quite interesting. Of course, it's nothing related with like health once you are an adult. Obviously, the completely different signature, like
Sure.
completely.
Yeah.
But they do work. So there is a developmental signature at epigenetic level too. In this case, it's not aging,
Mm,
that you can track quite accurately in the first months of life.
amazing. Yeah. I mean, obviously, I think it gets less sensitive as you kind of like as you move through. So it's hard to like, and the more data you have, the more smooth the curve is going to be. And so where do you arbitrarily draw the line? Okay, here's the first 6 months, and then here's the first 3 years, or anyway. And like I said, if this was something that you could just passively do, like you could just look and know, and then like how you would manage your or look in retrospect at your heart rate data or your HRV data, like if it became that simple to monitor in the future, and maybe it will, if we kind of put our creative hats on, like maybe we're measuring it in a very clunky, uneconomical way. Maybe like the instruments that we'll have in the future are going to be, very different, more like kind of like we see in Star Trek or something. But anyway, it's kind of a harebrained idea that, like, hey, would I want that as a parent for my child to know that, because, you go to the doctor with your child and they'll say, here's where you are on the height and the weight chart. Right. So where are you on
Yes.
that epigenetic chart? It might be a bad thing for right now. I think that the medical system doesn't need any more of that. But that to me seems kind of more like a better root cause measure as to like, oh, well, here's why they might be shorter. It's like your quantitative genetics says you'll have this height, but actually there's these things happening from an environmental perspective. Oh, malnutrition. And I suppose maybe blood gives us a lot of that. So it's like how much of this might be redundant. Yeah.
Yeah, that's quite interesting. So I think they are probably positively correlated, but weakly. That's the data we have seen
Mm,
in certain studies that they actually do anomics plus blood. Is that
mm,
obviously blood you have, we kind of know what you're measuring. The doctors know very well why they're measuring a certain biomarker,
sure.
like
Yeah.
cholesterol
Yeah.
and so on. We have a very good mechanistic sense. It's cheap to measure, highly scalable, a little bit invasive, but that's fine. But that's kind of like when you're about to go wrong or it is already quite wrong. The question is, what about before that? Like
Exactly.
like
Yeah.
we basically don't have anything like that because what happens is that healthcare right now is actually, we call it in longevity science, to make a joke, we call it sick care. It's basically when
Hmm.
you're sick, we're trying to fix you the best we can and just keep that heart beating and so on. And I think what we need is a truly healthcare, which is focus on primary prevention, focus on there is this like maybe a northern star of like this is optimal health. Let's drive you that way, because by going on that direction in your life choices, lifestyle, intervention, so on, you're actually getting away from the hospital for as long as possible. So
Hmm.
until that paradigm shift happens, and it's already starting to happen, but it's going to be a long road. I think this is what we have so far. And I agree with you. It would be
Hmm.
great to know, for example, if you have a kid, is your kid healthy in general? Should I, if I give him more blueberries every week and nuts, let's say, would is actually, biologically, am I helping him or not? Is that, eating maybe McDonald's once a week, is that bad? That doesn't make any difference. Like these kind of
Hmm.
things,
Hmm.
joining sports
Hmm.
and so on. Yeah.
Hmm. Yeah. Well, I mean, I think that's a good kind of segue like to the future. Like, what do you see? And you might even say, like, what are you, doing right now? Like what's NOVOS' like success story 10 years from now? I would suspect it's probably something like closing the gap that we just spoke of in the beginning, right? Like the age of disease or the window of disease. So like closing that gap. And yeah, so don't let me put words in your mouth, but what are you excited about in the future? Like you just, finished your postdoc, you're now new. Like what would you like to like look back at as a point of success, 10 years from now?
I think if I can contribute to this paradigm shift, that will be kind of like my professional life goal, because I think it's almost an ethical imperative in a way, which is I mentioned that we're going to spend more than a decade in a sick state. Is suffering at the individual level, at the family level, and on average, every single one of us is going to have to go through that. It's just the journey of life. But does it actually have to be that way? And,
Mm.
how much can we actually ameliorate that? And I think if I can contribute, to had a couple of healthy years, or at least enable that in some manner, I think it's a worthy life for me. So
Mhm.
that's kind of my goal. In terms of vision, I think, especially with longevity science too, is following exponential trend. We are now in the beginning of exponential trend. So longevity was, when I joined, one of the hardest things that I had to face was that it was frowned upon as an area of research, because people just like, there is no way, like aging is natural. There is nothing we can do about it. You're a talented guy, go study cancer because there is more funding there. So I actually had the professors worried about my future coming to me saying that I should really rethink
Mm.
it. As a friend,
Yeah.
they were not doing this out of any kind of interest or something. They were literally trying to be truly my friends, but
Mhm.
I still follow through, because it turns out that I think I was correct in my guess, which is, once people understand that we have enough data to show that the geroscience paradigm is quite well supported, that we should target aging, and the return on investment is so large, because basically you postpone, all the major cancer types, neurodegenerative disease, frailty, that I think is just going to be those paradigms that is going to just consume, maybe partially or most totally, like other industries, like the healthcare industry. In my opinion, in a couple of decades is going to be entirely about optimal health. And then when
Mm.
things go wrong, we have, all these decades of accumulated traditional medicine to kind of try to still, kind of save you. But the idea is that we are going to target optimal health at the society level, the policy level, public health level. We need optimal health, because, as you know, we're getting retirement changes get more and more and more postponed, extended, and at one point, it's just people don't have health to work, and the working population to general population ratio is going to be an economic disaster. So
Yeah.
I think a lot of things, there is public funding is going to jump on it, private funding is going to jump on it, because there's a lot of opportunity. So I think it's just a matter of time. So I'm really optimistic about longevity.
Yeah. Yeah. In actually, this is a great jump to, my favorite three questions that I asked all my guests, which is what's the key message that we were talking around today and that we came to? And, number two is like, who needs to hear it? And you've kind of alluded to that. And so I want to make sure I save a little bit of time, like, to talk about that notion of like policy or paradigm shifting. And then the third question is, who would you recommend as my next guest?
Sure. So maybe starting from the last one, I would recommend you. I would think Professor Brian Kennedy, uh,
Yeah, he's your PhD or postdoc
postdoc
supervisor.
supervisor,
Yeah,
is
yeah, yeah.
one of the leading scientists in this field. I've been in this field for a decade, and I think I'm like old generation in a way, because it's such a recent field. He's been there well before me. So he
Mm,
really was there before there was a field. In Singapore, they're doing a lot of interesting things. So he's in Singapore now. He used to be the director of the Buck Institute, it is the leading aging academic institution in the US. Uh,
mhm,
and in Singapore now is creating, basically we're actually trying interventions in humans, because Singapore is a really like forward-looking country in terms of policy.
mhm,
And
mhm.
they have this, they call it the Great Tsunami, which is basically what I told you about public health with a lot of old folks around.
Right.
And he's actually trying interventions. I don't want to spoil if you actually have him as a guest. So I think you should really talk to him.
Okay.
I probably can make an
Noted.
introduction too. Um,
I would appreciate that. That'd be awesome.
he's amazing. Also very nice guy to talk to. I would say that in terms of message, I think science is going to have a couple of years of healthy life in the next, let's say, decade. And that's just going to happen. How it's going to happen, we don't know. Is it going to be accessible to everyone, just to rich folks, just in developed countries? We don't know. But that we have a lot of therapies on the pipeline, a lot of startups with a lot of clinical trials going underway and so on. So it is going to happen. Growth is going to be exponential with AI and much more data. The way that we track age is going to get exponentially better. So I think basically aging is going to, in a way, is going to replace almost wellness and a lot of
Mm,
healthcare. So I think that's my message. It also means that it's highly scientific and highly technological. So you're
mhm.
not going to find, I mean, it's very unlikely. You might find, you might be right, but you're not going to find the latest aging intervention from a social media account, some influencer and so on. Like you need to have
Mm,
some kind of skepticism regarding that. And
mhm.
this is the trend that I think is inevitable.
Yeah. So the maybe point that I want to finish on with you is because you alluded to this before, is like, policymakers and you talked about like there's like an industry level, there's a government level, there's a a healthcare practitioner level. But I was thinking like on the level of the paradigm shift is like, how do we measure it was so I'd like to propose, and you tell me if I'm wrong, that
Okay.
we propose as a state level indicator of performance is like closing that gap that we started the conversation with, right? So, and let me just backfill this, and so it doesn't sound like I'm naive, right? Of course, things need to be economically viable, right? Of course, the margin needs to support the mission. I get that. The thing that I see, and I've learned just because I've had so many great guests on, like a lot of the systems thinker, going back to your origins, right? Like physics, is that the system can constrain the participants, if you will, do things that on the surface look good to support the system based on the goal, right? But actually are not very good. So, if your goal is GDP, right? And it's like, well, okay, but if we're stressing ourselves out and making ourselves sick to get there, or if we have an economically viable health industry, but people are sicker, is that the solution, right? So my proposal, maybe last point, maybe a question we leave with the audience, but I'd love to hear your thoughts on it, is like, is that a way, if we change the paradigm like that, like, how do you think people's behavior would change if that was the outcome we were all marching toward as the top priority?
Yeah. So
Yeah.
first of all, I would love that to be like the KPI for a health minister or something like that.
Yeah. Yeah. Yeah.
I would love that would be like literally the top KPIs. Like, okay, we are living very long, but if, especially in these developed countries, if you spend, 13 years in sickness, 14 years in sickness, I think something is wrong there.
Yeah.
Um, and I think we start tracking this relatively recent. Well, it's also a relatively recent field, but I
Mm,
don't know if it's known by policymakers. We track across all the countries. I don't know if it's known. And I don't know even if it's in their interest to kind of have that as a KPI. I hope so, but
mm,
I don't know.
mm,
At the individual level, I would love, I think maybe the change would also start from the people that once they hear these numbers and they understand the paradigm and see that is well supported, I think they can at least empower themselves at individual level and for their families and their loved ones, and maybe, adopt a healthy lifestyle. Just, sleep well, exercise, those 80% that anyone can do for free, basically.
mhm,
Yeah.
mhm. Yeah, amazing. Well, Diogo, thank you so much for joining. I've learned a lot, and I'm really excited to get this episode out. And just for the sake of our guests, where can people find you if they want to get in touch?
Yeah. So I am on the internet, I'm basically a scientist. So you can only find me on Twitter, liking papers and so on. But you can find me at novoslabs.com. I'm one of the scientists there. You can always reach out to our customer support team if you ever need anything and they pass it to me. So I would say those are the easier ways.
Amazing. I'll make sure I get those in the show notes. Again, thank you so much, Diogo. It was great having you.
Thank you, Jeremy. It was a pleasure. Thank you.
The vision Dr. Barardo offers isn't science fiction. It's a blueprint for a healthier human story. The tools exist. The data is mounting. The question now is, will we choose to act? Each of us, researchers, policymakers, citizens, as a rule in building a world where vitality is the default, not the exception. As you leave this conversation, consider the health span, lifespan gap in your own life and community. What might change if we made closing the gap our shared mission? The future of longevity isn't just about the years we gain, it's about the quality of the time we give back to ourselves and to one another. The vision is here, the science is here, the rest is up to us.